Hello everyone, welcome back to the channel, and today we are diving into a development that has caught the attention of engineers, analysts, and technology watchers around the world. A reported engine breakthrough from Israel that many experts say could change how we think about efficiency, power, and future applications across multiple industries. When people hear the word engine breakthrough, they often imagine something futuristic or even unrealistic, but in reality, most revolutions in engineering come from smart refinements rather than magic solutions, and that is exactly why this story is so interesting. At the heart of this discussion is the idea that traditional engines, whether used in vehicles, aircraft, or industrial systems, have long faced the same core problems: heat loss, fuel inefficiency, mechanical wear, and environmental impact. For decades, engineers have tried to push past these limits using better materials, smarter designs, and advanced control systems, but progress has usually been slow and incremental. What has surprised experts about this Israeli development is not just one single improvement, but how several improvements appear to be combined into one integrated system. According to early explanations, the engine design focuses heavily on optimizing combustion, energy transfer, and thermal management all at the same time, instead of treating them as separate challenges. This matters because in conventional engines, a huge amount of energy is wasted as heat, noise, and friction, meaning only a fraction of the fuel's potential power is actually used. If an engine can significantly reduce these losses, even by a small percentage, the real-world impact can be massive when scaled across millions of machines. One of the most talked about aspects of this breakthrough is efficiency, with claims suggesting a noticeable jump compared to existing designs in similar categories. Efficiency is the holy grail of engine development because higher efficiency means lower fuel consumption, reduced emissions, and longer operating life. Experts were reportedly stunned not because efficiency improvements are impossible, but because achieving them without dramatically increasing complexity is extremely rare. Complex engines often fail in real-world conditions due to maintenance issues, cost, or reliability problems, so simplicity combined with performance is what truly raises eyebrows. Another key point that has drawn attention is the use of advanced materials and manufacturing techniques that were not practical or affordable just a decade ago. Modern materials can withstand higher temperatures, resist wear, and maintain structural integrity under extreme stress, allowing engineers to push designs further than before. In this case, the engine reportedly uses materials that improve heat tolerance while also reducing overall weight, a combination that is especially valuable in aerospace and defense applications. Weight reduction alone can drastically improve performance, fuel efficiency, and range, making it a critical factor in both civilian and military systems. Beyond materials, the control systems used in the engine are also being highlighted as a major factor in its performance. Smart sensors and real-time adjustments allow the engine to operate closer to optimal conditions under varying loads and environments. Instead of running at a fixed or average setting, the engine can continuously adapt, squeezing out extra efficiency and stability. This kind of intelligent control has been talked about for years, but only recently has computing power and sensor technology become fast and reliable enough to make it practical on a wide scale. Another reason experts are paying close attention is the engine's potential versatility across different platforms. Rather than being limited to a single use case, the underlying principles could be adapted for land vehicles, aircraft, drones, ships, and even stationary power generation. Versatility is crucial because it determines whether a breakthrough remains a niche innovation or becomes a widely adopted standard. If the same core design can be scaled up or down without losing efficiency, it becomes far more attractive to manufacturers and governments alike. Environmental impact is also a major part of the conversation surrounding this development. With global pressure to reduce emissions and transition to cleaner energy, Any engine that can do more with less fuel immediately gains relevance. Even if the engine still relies on conventional fuels, higher efficiency directly translates into lower emissions per unit of power produced. In the short to medium term, this kind of improvement can be just as important as fully electric or alternative energy solutions. Some experts have also noted that this breakthrough could serve as a bridge technology, improving existing systems while cleaner energy infrastructure continues to develop. That bridging role is often overlooked but extremely important in real-world transitions. The reaction from the engineering community has been a mix of excitement and cautious skepticism. On one hand, the reported performance metrics are impressive enough to justify serious attention. On the other hand, experienced engineers know that laboratory success does not always translate into mass production or long-term reliability. Questions remain about cost, durability, maintenance requirements, and how the engine performs after thousands of hours of operation. These are the kinds of questions that only extensive testing and real-world deployment can answer. Another layer to this story is the strategic dimension. Israel has long been known for its strong focus on high-tech innovation, particularly in defense, aerospace, and energy-related fields. Breakthroughs in engine technology can have far-reaching implications for national security, economic competitiveness, and international partnerships. This naturally adds to the global interest as other countries and companies watch closely to see how the technology develops. At the same time, it also means that not all details may be publicly available, which fuels speculation and debate. From an industry perspective, established manufacturers may see this development as both an opportunity and a challenge. On one side, adopting or licensing new technology could give them a competitive edge. On the other side, integrating a fundamentally new design into existing production lines can be expensive and disruptive. History shows that even superior technologies sometimes struggle to gain traction if they require too much change too quickly. That is why the scalability and compatibility of this engine design are just as important as its raw performance numbers. There is also an economic angle that cannot be ignored. If the engine can be produced at a reasonable cost and delivers measurable savings over its lifespan, it could attract significant investment. Lower fuel consumption and reduced maintenance can translate into huge savings for operators over time. In industries like aviation and shipping, even small efficiency gains can mean millions of dollars saved annually. This is why financial analysts are paying attention alongside engineers and scientists. Public perception is another interesting factor in this story. Breakthrough technologies often generate hype, and managing expectations is crucial. If expectations rise too high too fast, any delay or setback can lead to disappointment and backlash. That is why many experts are urging patience and emphasizing the need for independent verification and transparent testing. Responsible communication will play a big role in how this development is ultimately received. Looking ahead, the next phase will likely involve extended trials, partnerships, and potential pilot projects. These steps are essential to move from promising concept to proven solution. If the engine performs as claimed under real-world conditions, it could open the door to a new generation of more efficient machines. If not, the lessons learned could still influence future designs and inspire new approaches. Either way, the research and innovation behind this effort contribute valuable knowledge to the field. It is also worth noting that breakthroughs rarely happen in isolation. They are usually the result of years of accumulated research, collaboration, and incremental progress. This engine is likely built on a foundation of previous work in thermodynamics, materials science, and control engineering. Recognizing that broader context helps us understand why such developments matter beyond a single headline. In conclusion, Israel's reported engine breakthrough has stunned experts not because it defies physics, but because it appears to bring together multiple advancements in a practical and potentially scalable way. Efficiency, materials, smart control, and versatility all seem to converge in one design, which is a rare and exciting combination. While many questions remain, the attention it has generated is well deserved. As more information emerges and testing continues, we will get a clearer picture of whether this technology truly marks a turning point or simply an important step forward. Until then, it serves as a powerful reminder that innovation in core technologies like engines still has the potential to surprise us. Watch the full explanation closely, because this is one development that could shape the future of how power is generated and used across the world.